Hello, everyone. Welcome to today's webinar, and thank you for waiting a couple minutes for us to get started. Today's program is titled Self-Leveling and Proper Substrate Prep for the Tile and Stone Installation. I'm Jim Olson with the National Tile Contractors Association. I want to welcome you and thank you for taking time out of your busy schedule to attend today's webinar that is sponsored by ARDEX. Before I introduce today's speakers, I want to remind you that during the webinar, you'll be muted. Please use the questions area on your computer to type in your questions, and we'll answer those at the end of this presentation. If the audio on your computer is poor, call the phone number on the invite to this webinar and listen on your phone. All NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented. This gives you easy access to watch and or share all current and past programs at your convenience. And I want you to know there's over 11 years of videos on there in regards to webinars and Tile TV. So please go to NTCA YouTube channel and check those out. It'll be very beneficial. All right, today's presenter, Terry Hall. He's a seasoned professional in the tile setting industry, bringing over 20 years of experience to his role as the technical field representative at ARDEX Americas. As a third-generation tile setter, Terry has honed his skills and expertise through decades of hands-on experience and dedication to the trade. Before joining ARDEX, Terry held a C54 and C15 contractor's license in the state of California for 14 years. He joined ARDEX in 2014, and he will showcase his deep knowledge and commitment to quality craftsmanship. At ARDEX Americas, Terry's leveraged his extensive background to provide exceptional technical support and training to clients, ensuring the successful application of ARDEX products. Based in Sacramento, California, Terry is known for his thorough understanding of the tile and stone installation, substrate preparation, and the use of engineered cements. His passion for the industry and commitment to excellence make him a valuable asset to the ARDEX team and a trusted resource for customers. Terry, welcome. Very much looking forward to your presentation. Thank you.
Thanks, Jim. Hey, good day, everyone. Thank you for attending today's presentation. As Jim mentioned, I am a certified substrate prep technician through the National Academy of Floor Covering Technicians. I conduct trainings throughout the year, specifically on substrate prep. And today's presentation is about substrate prep as it pertains to the tile installation. And as Jim mentioned, please use the chat function to post any questions that you may think of during today's presentation. And we should have plenty of time at the end to answer those. So we'll get started. So there are many types of substrates, but not all are suitable for tile installations. Suitable substrates are concrete, masonry surfaces, wood, exterior plywood, even OSB, metal decks for, say, ships or boats, existing tile, drywall, CBUs, cementitious backer boards, and then obviously leveling and patching compounds. What we do not want to install over are particle board, Luan, masonite, wood paneling, pressure treated or fire resistant wood, and felt paper, scribing felt. For the most part, the reasoning is a lot of those products, they will swell, they can delaminate, they're not structurally sound, and they're just not suitable for tile installations. So back when I started with my uncle in '94, we installed thousands of feet of 3x3, 4x4, 6x6 tiles on the wall. As for the floors, 8x8s and 12x12s were the norm, and the floors were flat enough to install on. When installing these smaller tiles, the substrates don't necessarily have to be as flat as they need to today. But nowadays, 24 by 48 inch tiles or even larger are a common sight in production homes and commercial buildings. These tiles need a substantially flatter surface to install over. The trend is bigger and bigger tiles. Like I mentioned before, we commonly see 24 by 24s, 24 by 48s, even larger tiles being installed in production homes and commercial buildings. Additionally, these tiles are getting thinner and thinner. As technologies improve, the prints are more realistic and tiles are getting much bigger. And as these tiles get bigger, the need for a flatter substrate is even more crucial. Mortar coverage, excuse me, is even more important as well. We don't want any voids underneath these tiles more than 2 square inches with your mortar. So imagine a chair leg on one of these tiles, for example. That point load over that void, I mean, we're reaching 2,000 PSI. And then that one spot can cause a crack to start. And you get a crack in one of these larger tiles, and it's an expensive repair. So this is why it's so crucial to have a very flat surface and get your mortar coverage. Our standards tell us that we need the substrate to be no more than 1/4 of an inch and 10 feet for a tile installation. For any tile with any edge greater than 15 inches, we need the substrate flatness to be 1/8 and 10 feet. And as you can see here, we also need it to meet 1/16 of an inch in 24 feet. And this requirement is in ANSI 108.19. Designers are specifying bigger and bigger tiles. Homeowners wanting bigger and bigger tiles. These tiles offer less grout joints, in return requires less maintenance, less cleaning. These tiles, they span a greater distance over the substrate, and they do not contour or bend to that substrate like the smaller ones would. So this is another reason why we need a very flat surface to work on. So this is an example of a typical construction site where substrate tolerances may not meet the need of a floor covering that needs to be installed. I mean, is that a high spot there? Is there 2 low spots? Depending on, who you ask, the general contractor, they're going to give you one answer and you got another answer. This is why it's always good to carry a 10-foot straight edge on a job and check the whole floor and try to find if you've got these variations in the substrate. Do we have to grind it down? Do we have to patch or build up? Maybe we have to put a leveling compound across the whole floor. You may laugh at this and it may not seem like it's common, but in reality, this is a very common site on most commercial installations that I've seen. By following proper prep guidelines, you will maximize long-term performance while reducing installation costs. More importantly, you will minimize costly callbacks and enhance your reputation as a quality installer. Preparation, I should say, reduces perspiration. We have the 5 keys to a successful installation, which are critical. And as number 2 is highlighted here, substrate preparation is one of those 5 keys to success. The ANSI A108.01 general requirements state a substrate must be clean, structurally sound, and solidly bonded, free of bond breakers, sealers, curing agents, form release. It must be flat and smooth and free of excess movement. Once that is achieved, we are able to just spread the mortar and set tile. Taking the proper steps at the beginning will allow you to install faster and more efficient at the back end of the job. Not to mention, you will be within TCNA guidelines. We need to get to clean, sound, and solid. Any loose, weak material and soft top layer need to be removed. The most effective way to achieve this is by mechanical means, such as shot blasting and/or grinding. In locations where we have contaminants, we must always mechanically remove them. Release agents, paint, drywall mud, sweeping compounds, oil grease, asphalt tar, etc. Old adhesives, all of these need to be removed mechanically. We don't want to use chemicals. In situations with new concrete, it should be wet or moist cured. No curing compounds used. You should remove any surface contaminants and then use a proper primer if necessary. If the concrete is treated with a sealer, we must be able to determine what type of sealer that is. And now if it's an acrylic, say, or an epoxy sealer, we just remove superficial contaminants and we can prime as necessary and install over that. If it's a urethane, we will need to remove that down to clean absorbent concrete and then use a primer as necessary. Now, the issue with sweeping compounds are most of them are petroleum based, and they contain waxes, which can leave residues. That is a potential bond breaker. And these are fine if you're just sweeping the floor, but if we're trying to install tile or a leveler or a patch or something like that over the top of it, then we don't want to use these. And I know some of them are out there in the industry and they say they don't leave a residue or they don't. I still wouldn't trust any of those. We always want to be careful. Just sweep. Sorry about that. Thought I had that on silent. I apologize. Preparing a substrate with existing adhesive residue. For example, say there was a different flooring that was removed and it left some of the glue behind. When we are directly in concrete, we need to scrape that adhesive down to a very thin layer without any excessive buildup. We do not want to use adhesive removers to take that glue off the surface. These products get down into the concrete, they will eat the glue, and they will get in the concrete. And then when you apply a primer or if you apply a mortar or something, it will eat those too. So they don't really know when to stop. So always use mechanical means. Now, sometimes an overlooked part of proper prep is repairing existing cracks. Now, products like this, it's a two-part polyurethane repair compound. It's extremely fluid, low viscosity. It allows it to penetrate deep into the concrete and repair that concrete back together. I know in the tile industry, everyone's talking about anti-fractures, and these products are good as kind of a precautionary over a concrete slab that doesn't have existing cracks in it. The whole idea is that if and when cracks appear, that these anti-fracture compounds will allow for some movement without affecting the tile. But if you do have existing cracks in the concrete, repairing them might be the best option by basically mending that concrete back together. So anyway, these are just one of the examples that you can do to address cracks. The application of both pourable underlayments and trowel grade underlayment products, they are not structural repair products. They don't make the surface any stronger. They only make it flat. And remembering our ANSI A10801 general requirements, we need to ensure that we start with a clean, sound, solid, and surface free of excessive movement. So self-leveling underlayment, or SLU, has a new name. The new name is flowable hydraulic cement underlayment, per ANSI 118.16. For this presentation, we'll be referring to it as FHCU, pourable underlayment, or simply underlayment. Now, the reason for this name change is these products, they don't self-level. They really don't do anything by themselves. They're more like a manually smoothing material. Can they level a floor? Yes, if using enough material, you can get a floor absolutely flat and level. But for the most part, what we're trying to achieve is a flat surface. So flowable hydraulic cement underlayment versus trowel applied or screeded patch. Several factors such as substrate, area, and depth of repair are just a few of the considerations when selecting a trowel applied repair or an underlayment. The type of substrate you are going over is also a major consideration. Are we going over concrete, wood, metal? Is there an existing floor? These choices affect your choice of repair products. There may be times where minor corrections can be made with a trowelable patch or even a ramping and repair mortar, such as spalls in the concrete. Maybe we need to smooth out existing tile. Maybe we're filling seams in a wood substrate prior to pouring a leveling underlayment, sure. Other times we may need to create a ramp, like a doorway from existing elevations or ADAs, possibly going up or down. So here we have a fireplace hearth that was in rough shape. The previous hearth was removed, leaving a very uneven surface. A pre-tile repair mortar was used to smooth this surface out to give a nice flat surface for the installation of the tile, or in this case, a granite slab or a gauge panel, something like that, getting that flat surface. So here's another place where a pre-tile repair mortar can be used in applications, like this fireplace, to square and plumb it. Everything that needs to get tile on it needs to be flat and smooth. In this case, the tile installed was very reflective. So if you just look at the reflection in this tile, you can see just how flat that is. So you see that door in that reflection of that tile, it's pretty flat. When we have a wooden substrate, many times it's necessary to fill the seams and any voids with a trowel applied patch to prepare for the underlayment. So you'll see in this picture where they fill the seams. You can also kind of see around the perimeter some spray foam, and we'll touch on that a little bit later. But you also want to walk around the floor and look and see if there's any missing, if there are voids in the wood substrate from nail holes that were removed or anything like that. Because if you're on the second floor and you pour a leveling compound on top of here and it finds one of those holes, it is going to find somewhere to go underneath. So always take a look and look out for that. So why prime? So primers do several things for us, such as prevent the substrate from pulling the moisture out of the underlayment. Also, they extend the working time for thinner pours, giving you more time to work with them. And additionally, they create a better bond to the substrate. And so let's talk about that just a little bit more. When we are installing tile or pouring an FHCU over certain substrates, they can be overly porous. Substrates like gypcrete and drywall are very thirsty. By priming them with a proper primer, you will reduce the porosity in those substrates, giving you not only a better bond, but more working time with your mortar or your FHCU. Now, obviously, when I refer to the drywall, we're talking about on the walls, not on the floors, but you can absolutely prime drywall with a proper primer before the installation of tile on the wall. I really like this photo. If you take a look at this picture, you'll see that the guy he's putting the primer down with a broom. And so the recommendation is to use a broom to basically agitate the primer into the substrate, getting it down into the pores and picking up any residual dust that may be there after vacuuming. If you're going over a wood substrate though, no broom is not necessary. We would recommend using a roller, but I know most of you out there, you probably use rollers, but give this exploded tip broom a try once. It works really good. So not all primers are the same. Make sure you have the right primer for the right substrate. Here they are using a flowable hydraulic cement underlayment directly over existing tile. This is a great option if you just need to smooth out the surface or if you need to build up the surface to meet existing elevations. Maybe you just don't want to tear out the existing tile. As long as the heights do not interfere with door openings or steps, this is a perfectly acceptable application. Flowable hydraulic cement underlayments are blended polymer modified cements with high flow characteristics. Primers can be single component, acrylic, or epoxy. Keep in mind, most underlayments will require substrate priming. Pourable underlayments may be approved for directly over wood substrates, metal substrates, or concrete. Be sure to confirm with the manufacturer the technical data information. This is important because some of these underlayments may have significant tensile pull and are not all made for all surfaces, okay? And if you're not familiar with tensile pull, as these products cure, they've grabbed onto the surface and they begin to shrink just a little bit, and they can have a significant pull. So if they're on a weak surface, they can pull themselves off the ground or pull up any contaminants under them, which is why we always want to make sure that that substrate is clean and strong, okay? Now, there are other products out there that have lower tensile strength, and those are the ones typically you were going over wood or going over metal and things like that. Like I said, that's why every manufacturer will have several different choices. Also, I would recommend using an expansion foam around the perimeter of the room, cabinets, any other penetrations, if they've been installed prior to putting down a leveling compound. So do you need flat and smooth, or do you need level? Sometimes level may not be realistic with thresholds and doorways, etc. In most cases, we are just looking for flat and smooth. We just want to meet that minimum requirement when it comes to, your quarters and 10 or your eighth and your 1/8 and 10 for these larger tiles. You see right here with this electronic level, okay, this is dead flat, 0.0, okay. Now, how do we know how much underlayment is needed? Maybe minor corrections, say 1/8 of an inch to 1/4 of an inch. You just got a rough surface. Maybe we have deeper gouges in the concrete and we need to get a little more thickness in there. Maybe 1/2 an inch to 1 1/4 inches. Okay. Larger areas that need deeper pours like this, they benefit from products with longer open times. So once again, every manufacturer is going to make a product that either is going to set up in just a few minutes or may set up a little bit longer. And so every job may not be the same. Smaller areas, quicker pours, sure. Larger areas, you may need to get a product that's going to give you more working time so you can get in and out of the rooms, or in and out from where you're mixing. Flowable hydraulic cement underlayment installations can help save time and money. By speeding up installation and minimizing effort on a perfect substrate, we are able to simply trowel out our mortar and set tile. High flow underlayments allow the material to go thinner and smoother, requiring less work. Heal is the ability for one batch or pour to blend into the next, or even to fill from walking across the wet material. So if you're not familiar with putting down a leveling compound, you'll see in this picture, they got cleats on. You are going to be walking through this material. Using the proper tools, understanding gauge rakes and smoothers, etc., are going to make that job a lot easier. It is super important to seal off all openings. We need to prevent any of the underlayment from flowing or escaping, thus not wasting material or maybe causing an issue somewhere below if we're on a 2nd or 3rd story, for example. Several options can be used to seal the wall to the floor connection, as well as around any penetrations like pipes and toilet flanges. Self-sticking foam, seal foam, spray foam, they're all useful tools to stop the flow from where you don't want it to go. This also helps during the curing process and will help minimize cracking in the underlayment. Now, myself personally, I'm not a fan of spray foam. I can use it around certain areas because I'm not concerned with how thick it goes, but That spray foam can get kind of sticky if you're not being careful. There are products out there, and you can see one of them in this picture here. There are products that are made specifically to seal off around the walls, around toilet flanges, registers, etc. Some are self-adhesive, so they'll seal off underneath the wall and give you a 1/4 inch expansion. Just look at your distributors, ask them, ask a sales rep and see what they have for you to use. So a couple of tools I want to mention is a gauge rake, and I'll show this little video for you.
Breaking the line across the back for the same reason, making it easier to tie in the next layer.
Okay, couple of tools, smoother, spike roller. Once you use a gauge rake, now that gauge rake is going to gauge how much material you're putting down. So if I want to put down a 1/4 inch, for example, I can set my gauges at a 1/4 inch and pull it throughout the floor and leave about a 1/4 inch. But I also want to use a smoother or a spike roller to relieve that surface tension. Okay. Now, surface tension, what that is just like water. It will be dry on the surface, for example, but breaking that surface tension and allowing, where the air is touching that, allowing that to relax, you're going to get a much flatter, much smoother surface. Both of these tools do that in different ways. If you're using the smoother, for example, here on the left, typically you're going to use that when you're going more than a 1/4 inch thick, 3/8, 1/2 inch, or 2 or 3 inches, absolutely. The spike roller, it's really designed for when you're going less than a 1/4 inch, because pressing down on the smoother, it doesn't take much effort and you're touching the ground. You may go right through the material when you're going very thin. So a spike roller is a really easy tool to use to break that surface tension. Other tools you may need are a mixing barrel, what we call smart buckets. These save a lot of time by measuring the right amount of water every time. Making sure you have the right mixer. You'll see in this picture here, not every barrel is the same shape, so make sure you have the right mixer for the right barrel. Using a pourable underlayment over electric radiant heat wires, it's faster, creating a beautiful, smooth substrate and protecting the wires from potential damage, like the electrician, painters, other trades, even from your own tools. So if you look at the picture on the left, and I've used that material before, you're dragging this metal trowel across these wires, where now with new technologies, we have mats that we can now put these wires into the mats and then pre-fill them with a leveling compound, or we can pre-fill them with the mortar. And then you come back next day, they're completely encapsulated and protected from, your tile installation, knives, trowels, etc. Pourable underlayments are also ideal for going over hydronic tubing, such as what you see here. Always be sure the underlayment you choose is approved for this type of application. I can speak from experience that not all underlayments are. It's best to check with the manufacturer or their technical data sheet. When we have a flat substrate, we can simply trowel out the mortar and set tile. Again, this is saving a huge amount of time during the installation and using less mortar. We're not picking up tiles, we're not buttering them up or spot bonding or putting more under there. A thin set mortar is just that. It is designed for a thin set application. But we should do all of our substrate prep prior to the installation of our tile. Backer board or CBU, these products do not make the floors flatter, nor do they make them any stronger. If the substrate is uneven or out of level, these CBUs do not make them any flatter or any more level. Okay? You'll need to use a flowable hydraulic cement underlayment to achieve flat or level. Overall, they are more efficient and they result in a better substrate to install on. Even with complicated situations like this, with multiple rooms and large open areas, they can also be tied together and perfectly smooth using the right material and the right amount of labor. I mean, who wouldn't want to sit on that picture there to the right? It's like a perfectly flat, smooth concrete surface. I mean, seriously, what could go wrong, right? I mean, I know this picture is kind of funny, but the point is how many things are wrong in this photo? And just like a job site, what could possibly go wrong? So here is a pourable underlayment over installed adhesive. Installing a rigid cement product over a soft, flexible surface or residue will result in cracking and/or disbonding. The installer should have scraped down the glue ridges to a stain in the concrete before applying a primer. In this case, the material was overwatered. The result is a very weak and powdery top layer and is not good to bond to. Another example of overwatering is a very soft, chalky type surface, and it's very easy to identify taking a coin, a key, or even a thumbnail and just scraping the surface of it. In this photo, a total disaster that could have been avoided. They did a poor job on the substrate prep and they wasted a lot of time and a lot of money. You can just see in the pieces that are flipped over, you see this white substance. Now, my first question would be, what is that white stuff? Because the leveling compound stuck to the white stuff, but the white stuff didn't stick to the concrete. And so that's the case of improper prep. So sometimes when a deeper or thicker application is needed to build up the substrate, a screedable mortar bed is the better choice. Maybe the installer is not comfortable using a flowable hydraulic cement underlayment and just feels more comfortable screeding the floor. Maybe you need to create a slope which cannot be achieved with a flowable hydraulic cement underlayment. Whatever the case may be, for an unbonded screed, make sure you follow F111-24 in your TC&A book, and for a bonded screed, F112-24. And your final considerations, substrate prep is key to all tile and stone installation success. There's always a right way. Stay in tune with industry trends and best practices. Be aware of the inherent challenges and use your resources. Okay? Industry guidelines, manufacturer technical services, supply partners, NTCA trainings, etc. Remember, lippage tuning tools or using more mortar under the tile are not suitable replacements for proper prep. Make sure your substrate is flat, without contaminants, and use the right primer when necessary before any tile installation. Remember the old quote, an ounce of prevention is worth a pound of cure. Whether you need a leveling compound or a mud bed, proper prep is always the best practice. Be disciplined, use your resources, use our industry standard as a guide, and do the right thing every time. And that is it for my presentation.
Terry, lots of
Yes.
great information there, and we have a few questions here and some comments, so we can run through those.
Okay.
In the very beginning, you were talking about the substrate, and the question that comes up, you actually mentioned it again about soft substrate, but what about gypcrete?
Okay, so gypcrete, there are certain leveling compounds that are gypsum based and can go over gypcrete, and you're going to want to ask your manufacturer rep the specific way to prime. I know that we say we want a double prime because they're so thirsty. So we'll do a double prime and then put the proper leveling compound over gypcrete.
Okay, great answer. If concrete is saturated with oil or grease, such as a commercial kitchen, is there any preparation steps that will allow us to install underlayment over it, or is a full mortar bed the only solution short of removing and replacing the concrete substrate? That was a lot.
That was a lot. Anytime oil, grease, anything like that is involved in concrete, we always recommend going down as deep as you need to get it out. Removing all the concrete is usually not something we can do, but typically that grease or oil is only down to about a ½ inch. And so cutting it out, bush hammering, getting it, removed that way, sure. Can you put a slip sheet and a floating mortar bed over the top of it? I would imagine you could. But yes, you want to get those out without using any chemicals, always mechanical means.
Cool. All right. I like this next one. Are there any screedable underlayments available for pitch to drain or sloped floors?
Yeah, there are. Yeah, as a matter of fact, we showed one earlier. There are products that can be used horizontally and vertically to plumb out walls and to create a pitch in a substrate, say to a drain or a pre-slope in a shower pan. Yes.
Cool. All right. This is a comment that's coming from a TCNA member and a ANSI member, and it says, thank you for reviewing and reviving and explaining FHCU versus self-leveling. And the comment is, we always use the term flowable mortar rather than self-leveling. So great job on that.
Yeah.
We've got some thank yous. Great job. We got, let's see here. You mentioned primer numerous times. When is a primer necessary, or are there times it's unnecessary?
So anytime you're on a non-porous substrate, a primer is usually necessary, with the exception of using an epoxy as an adhesive, for example, or a modified silane adhesive, something like that. Those will stick to a non-porous substrates. On a porous substrate, depending on what we're putting, if we're using a tile mortar, or if we're using a leveling or a patching compound, we're always going to use a proper primer, because like we said, not only does it give you a better bond, but it kind of temporarily seals that substrate so it doesn't rob you from the moisture of the product that you're putting down. It gives you more working time. So primers should be used as often as possible.
And are there different primers for plywood, concrete, etc.?
Yes, absolutely. Now, some of the primers will cross over from wood to concrete. They can be used on the same surfaces. It's usually when we're talking about a non-porous surface where you're going to have a different primer.
Okay. And are there any things that should be considered when putting tile over lightweight concrete?
You want to make sure that it is structurally sound. And when I say that, it's really not the installer's responsibility to determine that. A simple test of trying to scratch the surface, making sure that it doesn't seem weak. But in some cases, if there's a question, bringing in a structural engineer might be a good idea. But no, I mean, it can be done, yes.
Great. Fantastic program, Terry. And we got another one that just came in here. It says, newbie here. I have a customer who had carpet, then had a water leak throughout the home, and now wants tile. Is that acceptable to do a flowable flowable level mortar over it? I'm getting mixed up with the name now myself.
Yeah. So if I understand correctly, I mean, if there was carpet down, whether it was glued down or loose laid, once that's removed, when you get down to the concrete, make sure there's no contamination, paint, drywall, mud, adhesives, anything. Once that's removed, use the right primer, and then yes, you can use a leveling compound.
Yeah, great answers and great presentation. I want to thank you, Terry, and attendees. I want to make sure you know that all of these products are the standards, and for these are definitely listed by the manufacturer. Always check with manufacturer's recommendations on products and how to use them. Many of them will be mixed totally different than another one. So, you know, definitely look into that. I do want to real quickly just say thank you all to those that tried to get on our webinar last week and we had technical problems. We are scheduling that for July 15th, and please look for a invite to that later this summer. So Terry, fantastic program. Really, really enjoyed it. And oh, we got some more questions coming in. Here we go.
Okay.
What product do you recommend for shower wall screeding, wet areas?
Well, I mean, a traditional mortar is usually what people use. There are other products out there that are applicable for a vertical installation, but they're typically a rapid set product, and they're usually really designed for just touch-ups or repairs. So I would just use a regular sand and cement mortar, a sand, cement, lime mortar.
Great. Well, I think we have answered all the questions, Terry. I should say you have answered all the questions, and another fine presentation. Really appreciate it. I know you have another one coming later this year, and look forward to that. Attendees, thank you. Enjoy the rest of your week and have a great weekend, and you'll be receiving another invite coming soon for next week. So thank you all. Terry, thank you again. I hope you all have a great time, and we will talk to you soon. Bye now.
All right.